Thanks for, yeah, thank you again. Thank you for inviting me. This is great, and I'm happy to be here. So I'm going to be talking about really quickly how to actually get Python tools and libraries installed the right way, because Python is sort of one of the most used languages in the information security community, no matter what team you decide to be on. And a lot of people have trouble installing a lot of Python tools because of dependency hell and a lot of other issues, which we're going to be going over really quickly today, because this is a presentation that usually takes around an hour to get through, but I'm going to just condense this down to 20 minutes. So this is actually going to be somewhat of a challenge. So, but I'm up for that. So we'll see how it goes. So quick, who am I? I'm Marcello. I work over at Black Hills Information Security, as you probably well aware by now. I go by Byte Leader on the Twitters. I'm also the founder of Dependencies, which is essentially a community. It's now a community, which is helping to make hacking tool developers or InfoSec tool developers, making open source tool developing sustainable in our industry. So we're over at Dependencies on Twitter as well. That's the handle. So if you want to follow along with that, exciting stuff coming soon, by the way, inside scoop on that. It's exciting announcements coming there. So you should definitely follow along and see how that evolves. Okay, so this is what I'm gonna be trying to tackling in 20 minutes. So everyone just bear with me here. How to actually get multiple versions of Python on the same system to cooperate correctly, because a lot of InfoSec tooling doesn't necessarily have, or a lot of InfoSec tooling rather supports only a specific version of Python, right? And maybe a lot of that InfoSec tool or hacking tool, whatever you want to call it, only supports Python 2, which if you're a Python developer, it's sort of the ultimate sin to not port that over to Python 3, but it happens. Sometimes people abandon tools. That it all happens. So what happens if you need to run a tool that's written in Python 2, but you only have Python 3 available on your system? Well, hopefully I'll clarify that for you during this talk. And then we're going to be trying to address the my Python is broken problem. I hear this all the time from people. It's like, okay, I can't install anything. Everything that I try to run in Python just doesn't work. They wind up reverting VM snapshots. They wind up doing all sorts of things in order to get their Python installation working again. So we're going to be addressing the my Python is borked problem. Why is this happening? It's spoiler, it's not necessarily your fault. Sometimes this stuff happens without you knowing, but yeah, we're going to be going over that as well. And then I'm going to be sort of your Virgil during all this. We're going to be going from dependency hell to heaven. We're going to be talking about a little bit about VirtualEnvs and some easy buttons, and then finally conclusions. So again, like disclaimer, we're going to be focusing on like the practical things from the end user's perspective, right? We're not going to be focusing a lot on like development specific tools like pipenv or poetry. While those are useful, they're useful specifically only when they're useful generally, but they're specifically meant for Python development. They're not necessarily for end users in order to get Python libraries and tools installed on their systems like Kali or whatever next distro you decide to run. Okay, so we're going to be taking the perspective of the end user here. So the first circle of Python hell is managing different Python versions. What happens if you need a different version of Python to run a specific tool that is not available in your package manager? Because usually you can just do apt-get or whatever your distro's package manager is, apt-get Python 3, and it installs a specific version of Python 3. I think the latest version of Debian, for example, uses Python 3.7. Okay, so but what happens if you need Python 3.4, Python 3.1, right? How do you get multiple versions of Python on the same system to cooperate each other? And traditionally, what you'd have to do is you'd have to go out to python.org, right? You'd have to compile the Python version you're interested in manually from source, which I don't know if you ever tried doing that. I'll preface it by saying you probably should never attempt to do it because it kind of sucks. There's a suck meter there. There's a handy dandy suck meter there. It's a high level on the suck meter. It really does suck. I wouldn't recommend it. Thankfully, there's this awesome project called PyEnv. PyEnv manages all of this for you. So it automatically compiles Python for you. It manages the path and environment variables necessary in order to make different versions of Python cooperate on the same system. It's pretty easy to install, especially if you're on Mac. you could just do brew install pyenv using homebrew. If you're on any version of Nix operating system, you can refer to those GitHub links there. There's some dependencies that you need to install to get it to work on Nix, but after that, you should be good to go. And then the end result is that you can literally just type pyenv install and then the version of Python that you want. So pyenv install 3.8.5, for example, and then it'll just go out. It'll grab the version of Python that you want. It'll compile it all for you. You don't have to worry about anything. And then it'll install it. And then what you do is you can use the pyenv versions and pyenv global commands to actually switch between different Python versions. So right in this slide, for example, I'm using Python 3.7.7, which is installed by default. And I can see that by doing the pyenv versions command, there's like a little star next to the system entry there, which means I'm currently using my system Python version. And then you can use the pyenv global command to actually switch to a different version of Python, depending on which ones you have installed. In this case, I have 3.8.0 all the way up to 3.8.5. And I could just switch to it. I run Python 3 again. Hey, look at this. I'm running in Python 3.8.5 now, okay? So super easy, super, super easy. It takes the complication out of handling different Python versions on the same system. Fantastic. The second circle of hell, which is by far like the biggest one, is Python dependencies. So what do you go about usually, what do you usually do to actually install a Python tool right now, right? You usually do something like apt-get install tool A, so insert your tool that you want to install here. So whatever your distro's package manager is, usually try to see if it's available in your package manager. If it's not, you do pip3 install tool B, for example. What you'll notice is that sometimes you install different Python tools and then you try to run another tool that you've previously installed and then it just throws up on you, right? There's like tracebacks everywhere. It's like, what is going on here? And how do people usually solve this? Well, they usually try to reboot first, turn off and on again. That's usually the first approach. Revert VM snapshot. You try to fix things for a couple hours. You get super frustrated. You get high and or drunk trying to figure it out because, again, you got to relax because you're super frustrated. And then you give up, right? Because you're just like, screw it. I'm just not going to install it. Fine. You win Python. Again, there's a suck meter there, very high on the suck meter. So it really is not a pleasurable experience. So incredibly enough, the reason why this is happening is because there is a super easy way of borking up your Python install, quote unquote. You could just apt-get install some tool or library, and then you just pip install some tool and library. And you're almost guaranteed to break something this way. So what the real rule of thumb is, do not ever, ever, ever use both your package manager and pip to install Python tools and libraries. You either use one or the other. Do not ever cross the streams. And I added a little spinny effect thing here to really emphasize this, and added another little spinny effect here to doubly emphasize it, because you do not ever want to do this. You either stick with your package manager to install Python tools, or you use pip, one or the other, okay? Preferably your package manager. This is legitimately the cause of 80% of your Python issues, okay? Like 80% of all of the problems that you have installing tools in Python as an end user is because of this, because users, and it's not really well known, like outside of Python development circles, that this happens. And it's not really documented anywhere, which I really have no clue why it isn't. But this is legitimately the cause of most of your Python issues, okay? But why does this happen? Really quickly. Tool A requires cryptography 1.5. Cryptography is a Python library. Say you install tool A via a package manager, it also pulls down cryptography version 1.5, okay? Then you go about installing another tool, say tool B, right? Tool B requires cryptography 2.0. So what happens? Well, both your package manager and pip are writing to the same folder. They're both writing to your system site packages. So what this means is that pip really doesn't care that you previously installed the same version of the library, only it's the same library, only a different version of it, okay? So when you go install tool B, it'll just automatically overwrite the previous cryptography install, because it doesn't care. It's like the honey badger of Python install tools. Like it'll just completely overwrite the install. And say that unbeknownst to you, there have been breaking API changes in the cryptography library or bugs introduced between version 1.5 and 2.0. Well, the result now is that tool A is completely broken, and also everything that depends on cryptography, specifically version 1.5. So this is exactly why this happens. So the solution to this is isolate. What you do is you just create separate virtual environments for each Python tool, and so that so each Python tool's dependencies are isolated from each other. It's pretty simple. It's a pretty simple concept, right? So how do you go about doing this? Use VirtualEnvs. With VirtualEnvs, and I think I added a spinny effect. There it is, because I just went berserk with the PowerPoint animations on this slide, apparently. So the VirtualEnvs are basically just that. It's not a container of any sort. Don't get me wrong here. It's just a set of environment variables and path trickeries in order to make Python believe that it's installing things in a separate environment. Okay, so it's not like a container. It's not a VM. VirtualEnvs is sort of a misnomer in this particular case, but you can imagine it as just like a set of environment variables and path variables in order to make Python install things in separate environments. Okay, and that's exactly what virtual environments are. It's much more detailed in the actual documentation itself, which you can find at that link over here. And thankfully, there is now a VM module. I have no clue why this was not included in previous Python releases, but as of Python version 3.3, there is a VirtualEnv module, the VM module, so you can actually create these using a standard Python install without installing any third-party tools. I really have no clue why this wasn't included in previous versions of Python. That's just beyond me. Decisions were made that I personally think are ridiculous, but that's a different conversation entirely. Okay, so in practice, what does this look like? It looks like you create a new awesome project, right? You create a folder to start deving in, right? And then you use the Python 3 module, which is that -m there. With a -m, if you give -m to the actual Python 3 command, it'll use a module that's built into the language itself. And then you give it a folder. That will basically create all of the necessary scripts and variables and whatnot to actually spin up a virtual environment. You can then use the source command on the activate script that gets installed by this module to actually enter the virtual environment. And you'll see that your prompt will change here a bit. Your prompt will change, indicating that you are now in a virtual environment. So if you now do pip install requests, or really any other library, everything that you install in that virtual environment will be isolated from everything else, okay? So that's what it looks like from a development perspective. However, if you had to do this every single time as an end user to actually properly install Python libraries, you'd probably go crazy. So thankfully, pipx automates this entire process. So pipx is basically pip on steroids. Not only does it install Python libraries, but it installs them in an isolated manner. So you can just do pipx install, insert your tool here, and it'll go out, grab the library or Python package from PyPy, which is the Python package repository, and install it in its own virtual environment, okay? So essentially, you're probably gonna wanna use pipx for everything as a user, okay? You really shouldn't, unless you choose to only install things using your package manager, you should probably use pipx to install everything else, okay? Now note this is mostly meant for Python packages that expose command line tools, okay? So it's not meant for libraries. So for example, Impacket is a perfect example of this because it's a library. It's not exactly, it doesn't expose command line tools, although it does come with example scripts, right? But those example scripts aren't exposed to your command line through the Python package, at least the last time I checked. So if you try to install a Python package using pipx, or if you try to install Impacket using pipx, you won't have like secret stump available on your command line. So that's something to take note. But the end result here is that you just install pipx, you then run the pipx ensure path command, which just makes sure that pipx is set up correctly. And then you pipx install any Python package that you want. And the result is that it'll install it in an isolated virtual environment. And on top of that, it'll expose any command line tools that that Python package has to your command line directly, okay? So it's an easy button. It's 5 minutes to talk about ZipApps. Okay, so Python ZipApps. ZipApps are essentially the equivalent of Java jar files, okay? So they're the Java jar files in the Python world. Because sometimes you want to make your apps, Python apps, semi-portable. And by semi-portable, I mean you have a Python application that you want to run on a separate machine. That separate machine has already a compatible version of the Python runtime installed, okay? You just want to get your application to run on that machine in an isolated fashion and in an easy way. Okay, well, you can use Python ZipApps. And this is exactly a use case for that, right? I have tool A installed on machine A with all the dependencies nicely isolated. I want to run tool A on another machine, right? Without having to go through the hassle of installing pipx, or even though it's super easy, or creating a virtual environment. But the machine B has a compatible version of Python installed. How do I get my app to run on machine B? Well, ZipApps. So ZipApps is one of those things that are not well known outside of the Python development community for some weird reason, but they've been around forever. They've been around since Python 2. Like, they've been around forever. They're the draw file equivalent of the Python world. So by convention, ZipApps have the PyYZ extension. It's just a zip file. That's all it is. It's a zip file with all your Python source inside of it, okay? And funnily enough, pro tip, these actually run completely in memory, incredibly enough. So you can actually use these as like a red team tradecraft, from a red team tradecraft perspective. There's a lot of T's in that sentence, to actually run Python stuff in memory directly. So you can just pipe it through std and it'll just work, from what I gather. So that's all you really do. All you do is you really, and you can refer to documentation at that link, but you just package up your Python source code and all of its requirements in a zip app, and it'll just run natively, which is great. How do you go about creating a zip app? Thankfully, there's a ZipApp Python module, like the VMs module that we talked about here. You just install all of the application's requirements in a folder. You then use ZipApp to package that up in a compatible ZipApp so that the Python interpreter can run it. And you can also specify the Python version as a shebang line actually at the beginning of the zip, so that the system knows what version of Python this needs to be run in. And then you could just run it using the standard Python interpreter, or you could just set the executable bit and run it like a normal executable. The Python 3 documentation is a little bit of a misnomer, saying it produces a standalone executable. It's not truly standalone. You need the Python runtime installed in order to get this to work, okay? So it's not truly standalone. So the result is that you can now run an application that you develop on machine A on machine B with a compatible version of Python installed in an isolated way, and with all of its requirements, without having to install all of its requirements, and without having to, to deal with all of the dependency hell associated with that, okay? But the thing is, there are a couple of gotchas to this, and I'm gonna go through this really quickly because now I'm at 3 minutes. There are a couple of gotchas to this, mainly that ZipApps don't support Python. You can't run a ZipApp that has dependencies that have C extensions. So C extensions are a way of Python to talk to C. ZipApps don't support that because ZipApps run in memory, and anything with C does not like getting run in memory, okay? Let's just boil it down to that. Super horrendously way of explaining it, but let's just boil it down to that. So in order to get Python apps with C extensions to run using ZipApps, you can use a third-party library called Shiv, which was developed by the people over at LinkedIn. And Shiv is basically a slightly modified version of ZipApps, the ZipApp module in Python, only that it actually spools the content of the zip file to disk in order to make those C extensions actually run, okay? In order so you can actually use Python libraries with C extension. And spoiler alert, most Python libraries actually use C extension, especially if they're doing anything computationally expensive. So for example, Impacket, again, because I guess from a pen testing and red team perspective, Impacket is probably one of the most used libraries. It has dependencies that use C extensions, specifically the cryptography libraries that it installs. So like you wouldn't be able to use ZipApps otherwise. So you're gonna have to use Shiv if you want to package up secret stump, for example, in a ZipApp, which is totally possible. Silent Trinity and CrackMyExec, which are 2 projects that I created. I should probably stop gesticulating a little bit less. I just punched my mic by accident. But Silent Trinity and CrackMyExec are 2 tools that I created that actually do have ZipApps available on GitHub. If you go to download, if you go to the releases section or the download section for these tools, you'll find ZipApps available. It's not marked as a ZipApp, but they are really ZipApps. Oh, and this is an example of how you would actually build one using GitHub Actions. So GitHub Actions is like a CI/CD thing on GitHub, and you can totally automate the creation of building and packaging Python applications in ZipApps. Finally, if all else fails, Docker. Docker is it's not exactly lightweight. You can easily get Docker image overload on your system where it's like 15 gigabytes of just Docker images everywhere. But it's definitely super easy. So there's that. So you can totally do it. There are a couple of Python in Docker gotchas. You can use that link there, which is basically the Bible of Python, of how to package Python apps properly in Docker. It has super amazing resources, but really quickly, don't use Alpine images to package your Python apps in Docker. Only stick with Debian-based images because Python is not Go. They're different languages, so they just work. You're not going to get slimmer images even though you're using the Alpine image. Just, quick on that. And in practice, this is how you would actually run a Python app in Docker. So you git clone whatever tool you want from git clone whatever tool you want from GitHub, and then you do the Docker run command, and it'll drop you in an environment, and there you go. You have your Python app in Docker. And finally, hopefully this was useful, and just on time actually. So hopefully this was useful and a really quick intro to actually how to install things correctly in Python.
That was awesome. And you won the bet. You did actually go through an hour of material in 20 minutes. I had doubt. I had my doubts, but you have done it once again, always impressing us.
I had my doubts.
Thank you.
You're welcome. Thanks again for the invite. And yeah, hopefully it was useful.